guys. So we didn't get a chance to do all the parts of the FRQ. I know that window's bad. We didn't get a chance to do all the parts of the FRQ in class last week. We just did a couple parts. So I'm going to go ahead and do all 5 parts right now so you can see that. So let's switch to, how do I switch? I'm so dumb. Oh, there we go. Okay, let's switch to that. Okay, here we go. All right, so here's the one from class, given this graph. So given the graph of this function, which is the graph of f, defining g as the integral of -1 to x of f of t, finding these different values. I'm going to go ahead and do all 5 parts, but we did do some of these in class. Okay. All right, so g of 2 would be the integral from -1 to 2 of f of t dt. Okay, given f is a graph, that's going to be the area from -1 to 2. All right, so this area and this area. So it looks like we're looking at a -1/2 1 times 6 and a +1/2 2 times 1. So -3 plus 1 is -2. G double prime, or excuse me, G prime of 2. Okay, well, G prime of 2 is going to equal f of 2 because G prime of x is the derivative of the integral of f of t dt from -1 to x, which is going to be f of x. Okay, second fundamental theorem, second part of the fundamental theorem. So f of 2 is, or G prime of 2 is equal to 1. All right, so that's part A. Part B, average rate of change. So average rate of change would be g of 6 minus g of 0 over 6 minus 0. Average rate of change of g. Remember, g of x is -1 to x of f of t dt. So this is essentially another area question, okay, because when we're figuring out g of 6, that's going to be the integral from -1 to 6 of f of t dt, which will be all that area, this area, 1, 2, 3, 4, 5, and that all together. All right, so that's the -1/2 times 1 times 6 for the triangle that's under the x-axis, plus 1/2 times 5 times 2 for the triangle that's above the x-axis, and then -1/2 1 times 1 for the triangle below. So negative area here, positive area here, negative area here. So all of that, -3 plus 5 minus 1/2 is 3/2. Okay. G of 0, integral from -1 to 0 of f of t dt. So that's just the -3 because it's just that guy. So my average rate of change is 3/2 minus -3 over 6 minus 0. You do have a calculator, so you should have everything worked out, I believe. I don't know. I'll be interested. I have to watch some tapes on this and see, or watch a video on this and see what they say about that. But 3 halves plus 6 halves would be another 3 divided by 6. So 9 halves times 1/6 is 3 goes in there 2, 3 goes in there 3. Final answer 3/4. 6 halves would be 9 halves over 6. 9 halves, 3 times 2, 3 times 3. Yeah. Okay. So, not really a lot of difference between parts A and part B, kind of using the same skills. I'd be surprised if we saw both of these parts in the same question, or because you're kind of doing the exact same thing. This one's a little bit different, and this one does have the G prime of 2 part. But, you know, average rate of change, definitely should know how to set that up. Okay. Points of inflection. G has points of inflection when G double prime changes sign. Okay. So that's the first thing you're going to say. It's like, okay, if I want points of inflection from G, I need G double prime changing sign. Okay. Now, G is the integral from 1 to x of f of t dt. So G prime is equal to f of x. So G double prime is equal to f prime of x, which is the slope of the f graph. That's how where we're gonna get that in this problem. Okay. So when we talk about G double prime, we're allowed to do it because we can talk about G double prime changing sign, and we're going to indicate if this is exactly where I'm going to get these G double prime values. All right. Now, start things off though, G double prime equaling 0 or undefined for points of inflection. G double prime, where is that going to happen? Well, that happens at x equals -1. Okay. That slope at that point is undefined. At x equals 0. So all these points of where the derivative, where f prime wouldn't exist, because f prime is G double prime. So all those weird sharp points. Sharp point, 1, 2, 3, 4. Is that 4? X equals 4. X equals 5. All right. Now, the number line is not going to give you, it's not sufficient for just having the number line. Doesn't enough to count having the answers. You're going to have to kind of talk about what the number line tells you. But if I look at the graph, I have a negative slope and then a positive slope on either side of -1. At 0, left side and right side are both positive slopes. And then I have a negative slope and then another negative slope. So I would say G double prime has, no, not G double prime. G has points of inflection at x equals -1, x equals 4, because G double prime changes sign. Okay. I think something that would be good to have on a cheat sheet as you're working on a test is sort of how to justify things. All right, so what are you going to need to say to justify a point of inflection? What are you going to need to say to justify a min or a max. What are you going to need to say to justify increasing, decreasing? And then you're going to have to talk about, okay, this is how I'm getting that. So that's what they're going to look at. This is easy enough to write down. So you're probably not, and you have the ability to look at something for that. So you're probably not going to get credit for saying that. You're probably going to get credit for saying that and then talking about what you're doing to get that. And so getting those right answers is going to be super important. I think less points for knowing how to do things that you can look up, and more for showing that you can do them. All right, absolute max. Absolute max, you should be thinking about candidates, table of candidates. And -2 and 6 are two key candidates. Candidates for absolute maxes and mins are places where your derivative is equal to 0. Remember, G prime is equal to F. And F equals 0 at 0 and 5. So I need to find the value of the G function for each of those, and whichever one gives me the biggest answer, that answer is my maximum. Okay? The table of candidates is going to be your justification. So we're going to need G of -2, G of 6, G of 0, and G of 5. And remember, G of x is the integral from -1 to x of f of t dt. So these are area questions again. Let me see, were we told anything else? Let me go back to the stem for a minute. No, we weren't given anything. Okay. Oops. Let's go back. Okay. So G of -2 is the integral from -1 to -2 of f of t dt. That's going backwards. Okay. That means, what was these? I apologize. Oh, so that means that's going to be, even though it's under the x-axis, we're going backwards. So that's going to be a positive. You can count that as a trapezoid, or maybe as a little rectangle there, and then that triangle. That's probably what I would do. I'd say 2 for that, and then a half, and 1, and 1, 2, 3, 4. So it looks like the whole thing is 4. From -1 to 6. Well, we figured that out on part B. G of 6, we got to be 3/2. And G of 0, we got to be -3. So the only one left is G of 5. That's going to be my integral from, whoops, not 1, from -1 to 5 of f of t dt. And so that's the -3 for that guy, and then 1, 2, 3, 4, 5. 1/2, 5, 2. That's going to be 2. So absolute min for G is -3 at x equals 0. This work is the justification. You don't have to say anything else. You have all the places where you could possibly have the absolute minimum. You have the endpoints, you have the critical values, you have the function value at each of those, and that's the lowest one. All right. And then part E. This is the part we did in class, but I will run it one more time. Relative min, relative max, or neither. All right. So, relative min or max of h of x. First thing we need is it has to be at a place where h prime of x is equal to 0. So if I write h prime of x, that'll be g of x times 1 plus x times g prime of x. So h prime of 2 will be g of 2 times 1 plus 2 times g prime of 2. Okay. Once again, integrals to do from -1 to 2. I think that's the one we did at the beginning, right? G of 2, yeah. G of 2 is -2. And g prime of 2 was 1. So, possible min or max at 2. Possible min or max for h at x equals 2. No, we could do first derivative number line around 2 for g prime, or actually for h prime. We can, or we can use the second derivative test. Basically, we're going to look at whether the second derivative is positive or negative at x equals 2. Okay. So, my second derivative. G of x, xg prime. Okay, let me do that for a second. All right, so my first derivative was g of x plus xg prime of x. So my second derivative is going to be g prime of x plus g prime of x times 1 plus x times g double prime of x. H double prime then at 2, this is going to be g prime of 2 and g prime of 2 times 1 and 2 times g double prime of 2. Okay. All right, so we've already had the information about g of 2, or not g of 2, g prime of 2. Okay, g prime of 2 equals 1. So this is 1, and this is 1 times 1, and this is 2. And g double prime at 2, I can calculate the value if I want, or I could just say I know that it's positive. G double prime of 2 is the slope of f at x equals 2. So I know if this is a 1 and this is 1, and that's a positive, and this is 2 times a positive, that h double prime of 2 is going to be bigger than 0. That means we're looking at h being concave up around x equals 2, which means h has a minimum at x equals 2. if you have a concave up section, the 0 point for the derivative is at a minimum. That's it. Week 3 FRQ. That's the practice one. You need to make sure you do the homework one and get that submitted. Thank you.